Hi everyone, welcome to day 4, Hills and SAS. Here's the first question. In a right triangle RST below, altitude SV is drawn to hypotenuse RT. If RV is 4.1, let's write it in, and TV is 10.2, what is the length of ST to the nearest tenth? So I'm going to put an X at ST. Notice that there is nothing on the altitude, which is SV. So if there's no variable or no number on SV, then it has to be a hills question. Hypotenuse over leg, leg over side. So the hypotenuse of this triangle, I would have to add 4.1 plus 10.2. And that equals 14.3. That's our hypotenuse. So that's 14.3 over my leg, which is ST, which is X, is equal to the same leg, which is X, over the side. And the side is right across in this triangle, which is 10.2. Cross multiply. So X times X is X squared. And 14.3 times 10.2 is 145.86. To get X by itself, we take the square root. And X is equal to approximately 10.07. And it wants us to round to the nearest tenth. So that's 12.1. Choice 4. To summarize Hills and SAS, first we have the first theorem. Each leg of a right triangle is the mean proportional between the hypotenuse and the projection of the leg on the hypotenuse. So for example, this is our hills. So let's look at the letter correspondence of the first one. AB, which is my hypotenuse, over CB, which is my leg, is equal to the leg, CB, over DB, which is the side in this case. So we have hypotenuse over leg is equal to leg over side. Next, we have our other proportion. AB, which is still the hypotenuse, over CA, which is the other leg, is equal to CA over AD, which is the other side. And remember, we use hills when there's no number on the altitude, which would be CD. Next, we have the theorem, the altitude of the hypotenuse of a right triangle is the mean proportional between the segments into which divides the hypotenuse. So this is our SAS, which is side over altitude is equal to altitude over side. And we like to put a 1 and a 2 here because they're different sides. So for example, let's look at this proportion. AD, let's call that my side 1, over CD, which is my altitude, is equal to my altitude CD over DB, which is my side 2. And again, remember, we only use SAS when there is either a variable or a number where the altitude is. Here's the next question. In the diagram of right triangle ABC, CD intersects hypotenuse AB at D. If AD is equal to 4 and DB is equal to 6, which length of AC makes CD perpendicular to AB? So I'm going to put a X where AC is, because that's what I'm asked to solve. Take a minute right now and pause the video to solve for X. So this is a hills question because there is no number or variable at CD, which is the altitude. So notice that AB is my hypotenuse. I have to add 4 and 6 together to give me 10. So H over L is equal to L over S. My hypotenuse is 10. Over my leg, which is X, is equal to X over my side, which is the 4 and the smaller triangle. Cross multiply, x squared is equal to 40. Take the square root of both sides. So x is equal to radical 40. Now you can use your calculator and type in radical 40 and type in the answer choices to match the decimals, or if you know the largest perfect square to go into 40 is 4 and 10. So radical 4 turns into 2, radical 10. Choice 2 is your answer. Again, using the calculator to check your decimals is a great tool. Lastly, in triangle RST, shown below, altitude SU is drawn to RT at U. If SU is equal to H, UT is equal to 12, so write in a 12 at UT. RT, which is the entire bottom, which is the hypotenuse, is 42. Which value of H will make triangle RST a right triangle with angle RST as a right angle? So I'm looking for H. Now notice, I do not have RU. I only have UT and the whole bottom RT. So to find RU, I just have to subtract 42 minus 12 to give me 30. So RU is 30. Also notice that H is on the hypotenuse. So if I have a variable at the hypotenuse, I have to use SAS. Side over altitude is equal to altitude over side. So I will start with the 30. 30 over H is equal to H over 12. Again, if it's helpful, we do this little loop that tells us it's a SAS question. Cross multiply, H squared is equal to 360. Take the square root. H is equal to the square root of 360. Now again, you can use your calculator to match the decimals. Otherwise, radical 36 is the largest perfect square to go into 360. And that turns into 6 radical 10, which is choice 2. I hope that was helpful. Now log on to Castle Learning. Thank you.